Thank you, Krish. So folks, we will now cover the topic on how we can establish feeds and speeds based on the material that you're going to be using for cutting this part, and how the feeds and speeds computation, the calculator that's built into the application, can be effectively used for it. Now, as you go through the workflow of defining your tools and establishing the workflow for machining the part, there's a material option in here where you can choose the material type that you're going to be using for programming this part. Now, as you select the material pull-down menu here, there's a standard list of materials that's by default included with the application. So you can choose the material type from this list, or if the material that you're looking to work with is not on the list, you can customize the list. We'll talk about that in a short moment. So in this particular example here, I'm going to pick the material as aluminum 6061, and this information is being read from a materials file, and I'll get into the details in just a moment. Now, as you define the material type, and as you go through the process of defining your tool, where you can specify the tool material type. So what we initially defined was the stock material type we're going to be cutting. Now, in this particular tool dialog, you're going to be defining the tool material type you're going to be working with. This could be carbide, it could be high-speed steel, or ceramic. So if you select the material type as high-speed steel, HSS, and then as you go over to the tab called Feeds and Speeds, now down at the bottom of the tab, there's an option called Load from File. Now, as you select Load from File, you will notice that the material that you chose for the stock material is automatically set as you define this in the material dialog, and the tool material type is also automatically set since you define under the Properties tab in your tool definition. Now, from the material file, it automatically has information of the surface speed for the stock material and the corresponding tool material, and the feed per tooth, and also there are certain input variables like your tool diameter, number of flutes. Those are the variables that are used in establishing the spindle speed and the cut feed rate. Now, the surface speed is defined as how fast the cutter periphery is traveling with respect to the workpiece. So you can use the suggested surface speed for the material that you're cutting to determine the spindle speed. And also you may want to keep this in mind, the larger the cutter, the bigger the surface speed will be. So our feeds and speeds calculator is using the information that you have for the surface speed and also the feed per tooth to establish the spindle RPM and the cut feed rate. Now, the feed per tooth is defined as how fast the tool itself is moving with respect to the workpiece. And this is a property of the cutter. And the higher the number of flutes you have, the faster would be your feed rate. So if you notice here, for the surface speed and the feed per tooth, and the diameter of the tool in this case happens to be 1/2 inch, and we established the number of flutes as 2 under the properties dialog, the spindle speed and the cut feed rate is computed. Now, these information that you're seeing in the feeds and speeds dialog could be used as a good reference for you to establish the most ideal feeds and speeds for your machine. Now, you also may want to take into account your, the capabilities of your machine, depending on what is the maximum spindle RPM and the feed rates your machine can handle. You may also want to take that in account, but this can be used as a good reference as a starting point in here. Now, once you select OK to accept these parameters, you will notice that the spindle speed information is automatically transferred into the spindle value, and the cut feed rate is also transferred in here. And also the system automatically computes and applies a percentage of the cut feed rate for your plunge, approach, engage, retract, departure, and the transfer feed rates. Now, we'll show you where these defaults are set. We did talk about it a little briefly earlier during the webinar. As you go into CAM preferences and feeds and speeds, you will notice that the plunge feed rate is set to 50% of your cutting feed rate. So if your cut feed rate is computed as 24, the plunge feed rate uses 50% of that, which happens to be 12. The approach is set to 75. The engage is also set to 75, and then the retract, departure, and the transfer rates. Now, these percentage defaults can be changed, and you can change it based on what would be more appropriate, what is more suitable for your machining needs. But these are the default settings in here, and you can use these settings, or you can change them to the preferred settings. Now once you establish this and save the tool to a library, those information are automatically saved like we talked about earlier. So you can establish the feeds and speeds using load from file directly from the tool definition dialog and have it saved to a tool library, or you could also go into a machining operation. You go into the feeds and speeds tab, and you can use the same load from file option in here as well to compute your feeds and speeds based on the stock material, your tool material, and you can compute the feeds and speeds from here as well. So the feeds and speeds, the load from file option for feeds and speeds can be accessed both from the tool definition dialog as well as from the feeds and speeds tab in any of the machining operations that you're working with. Now, there's one other nice feature I want to point out in here is, rather than having to go through the process of computing the feeds and speeds from the file for each operation, you can choose to automatically compute it from the feeds and speeds file by selecting the default for new operations to use from the feeds and speeds file. So what this does is, when you change the machining preferences to feeds and speeds file, as you create a new machining operation, and once you selected the tool, the feeds and speeds in here are automatically computed, so you don't have to go through the process of selecting the load from file and then selecting OK in here. It'll automatically populate the feeds and speeds from it automatically for you. So unless you want to go back and change it, you can always call upon the feeds and speeds file dialog, but selecting use the feeds and speeds file will automatically compute the spindle and the other feed rate parameters when programming new operations, if you have selected it to use feed rates for new operation from the feeds and speeds file instead of the tool in here. Now I'm going to talk about the material file, where this is saved, the feeds and speeds, and show you how you can customize it as well. Now I'm going to open up a Windows Explorer in here, and you'll notice that under Program Data, Microsoft Corporation, you pick your corresponding CAM product. This could be Visual CAD-CAM. You could be using RhinoCam, Visual Cam for SolidWorks, or even Alibre Cam. So you go into the folder, and there's a folder in there called Materials. So you open up the Materials folder, and you'll notice that there are texture map files for several different material types, and also there's two XML files in here. There's one for inch units, and there's one for millimeter units. Now, you can edit these XML files using any text editor of your choice. I'm just going to pick Notepad in here, and you'll notice that the information that's contained in this XML file is what's automatically being populated into the load from file. So you'll notice that for material type aluminum, if you're working with 2024 or 6061, for example, you'll notice that the type of operation is milling, and the tool type here is defined as carbide, and the surface speed in here, which is defined in feet per minute. So it's set in this particular material file, and the feet per tooth, which is the property of the cutter, which is also defined here in IPT. So this information that you specify in the material file is also, as you can see when you go to your tool definition in here and go to load from file, this information for the surface speed and the feet per tooth is populated from this particular file. So in this particular case, I've chosen the material to be, the tool material to be high-speed steel, and you're seeing that the information for the high-speed steel is, this is where it's being read from. Now if you need to modify or change it, you can modify the default XML file, or you can also have one or more XML files saved in the same folder under the materials folder, and you can choose which material file to use for computation of your feeds and speeds. You can also add additional material types, or you can delete material types that are in the list. So if you're working with different types of wood, you can have one for each type, or one for oak, mahogany, different material types you can customize. You just need to make sure that you maintain the same format and also use the same type of tags in here as you see for each material type, with the opening and closing tags for material and the names. And if you also have a texture file for, you can assign it the texture file, you can use the bitmap file to map to it. So this is the format in which the material file is defined, and you can have one or more of these material types defined and we can use them. We can pick which material file to use. So if you go back into this folder, let me go ahead and make a copy of this in here. And I made a copy of this folder file, and I'm going to call this file number 2 or 3, whatever you want to name it. And as you change the name for it and you go back into the application, you go back to the materials dialog, right in here you have a drop-down menu to choose which material file to use for computation of your feeds and speeds. So you can have one or more defined, and you can customize each of these material files to your machining needs, the type of materials that you're going to be working with. So once you have the material file set, when you compute your feeds and speeds, it's going to use that information. When you pick load from file, it's going to read that information from the material file to establish your feeds and speeds. Now, folks, if you do have any questions, you're welcome to post them in the questions panel. I'm going to hand this back to Chris, so he's going to give you some more additional information about the feeds and speeds.
Uday, before you do that, could you just bring up the calculator and hit the help button and to bring up the online help?
Certainly, Joe. So I have the feeds and speeds tab. I'm going to pull in the calculator and select help. And this is how we can access the online help for the feeds and speeds load from file dialog.
Thank you, Uday. I was just looking to see if we have the data format for the table in the online help somewhere. There was always a question about that.
I believe we do have it documented, and it should be under one of the topics. I can try to look for it. And
okay, we don't need to do that right now. We can send it out by an email once we have that. So, and also I just put up that blog article on how to customize this material file. So that's also a very good resource if you're interested in doing that. Thanks, Uday.
Thank you, Joe.